Okay, for number one, here's our equation. Y is the same as x minus 6. Okay, so we're going to plug in each of these x's to find out our y. Alright, so the first x is negative 5 minus 6. Negative 5 minus 6 is negative 11. That'll equal y. Next one is negative 1. So I put the negative 1 in. Negative 1 minus 6, and that's negative 7. The last one is 8. 8 minus 6, and 8 minus 6 is 2. So I'm looking for a negative 11, negative 7, and a 2. Looks like that's option B. Okay. Alright, number 2. The mapping diagram shows a function. Key thing here, it says it shows a function which could be a possible value for the missing in value. Okay, so since it has to be a function, every y should just have one x. Okay, and since there's already a 7, it's not A. There's already 8, it's not B. There's already a 9, so it's not C. Only value of x that isn't shown here is option D. Okay. Number 3, why is this a function? Alright, so if I look here, look at each value of x. Okay, there's only one line coming from each x. Okay, so since there's only one line, the first ordered pair we have here is 4, 2. Right, then we have a 5, 2. And then we have a 7, 6. Right? No repeats in the x. There's only one arrow coming from any x value. Any of these in the domain, there's only one. So each number on the left only has one arrow coming from it. That's the one. So it's option A. Okay, let's take a look at number 4. Which table shows a function? So if I look here, for a function, there's only one value of each x has only one y value. Okay, so on this, the left side is x, the right side's y, right? Typical standard format. The input always means the x, output always means y. Okay, so x, y. Okay, alright, so there shouldn't be any repeats in the x column. That's our visual cue. If you look at A, 1 repeats itself, so does 2. Okay. In C, 3 repeats itself several times. In B, this 3 repeats that one value of x. That 3 has 2 different y values. Okay, but in D, 15, 25, 35, 45, there are no repeats in the domain. Okay, each of those x values has just one y value. Okay, all right, number 5. As the input is increased, so input again means x. Okay, what is happening to the output? What's happening to the y? Okay, so as the x is increasing, look, it's getting bigger as you go down. What's happening to the y? 11, 2, negative 7, negative 25. The y, okay, is getting smaller. So the output is decreasing. Okay, so the output is decreasing. It's getting smaller. Okay, just waiting for the camera to catch up there. All right, number 6. Which set of ordered pairs is not a function? So we're looking for repeats in x. Okay, so it's not a function. We want the one that's not a function. So we want to find the one where there's a repeat in x. Alright, in A, let's look at the x values. 0, 1, 2, 3. Alright, no repeats. In B, there's a 7, an 8, a 9, and then a 7. There's a repeat in this x. That one x value, 7, has 2 different y values. Right? So the answer here is B. That one is not a function. It has a repeat in the x. Alright, number 5 says, back, which of these is not a function? So we need to find one that does not pass the vertical line test. In A, anywhere that I draw a vertical line, okay, I'm only going to hit the graph one time. Okay, that's a function. Okay, passes the vertical line test. In B, anywhere I draw a vertical line, it hits the graph only one time. That's a function. But in C, there's a couple different places, several different places, where if I draw a vertical line, okay, it hits the graph right there, hits the graph right there, 2 points. That vertical line hits the graph in 2 points. That's a repeat in the X. So for where the vertical line that I drew is this point here is 1, 3. This point here is 1, -4. Right? There's a repeat in that X. This is not a function. Okay, it didn't pass the vertical line test. Okay, so C is not a function. Number 8, it says Norma made the graph below to show the relationship between the age and the value of 12 different cars. Which value, when removed from the graph, would result in the relationship being a function? Okay, so you gotta think here, if we remove one, which one would make it a function? So the one that we remove would be in line with another one on the vertical line test. Okay, so if you look at these points, I'm going to go through each of these and I'm going to see which 2 points share an X value. If you look at this last one here where X is 9, okay, when X is 9, there's 2 different points. Okay, so if I remove one of those points, it would result in a function. So I want a point in my options where X is a 9. Right? So look at option B, it says 9, 3. If I move this 9, 3, well then, right, this graph would be a function. Okay, if I remove this one, if I take this one away, that 9, 3 one, now it'll pass the vertical line test. Okay, right, I'm looking at this, I'm looking at, right, those 2 right there, where the X is 9. Okay, if I remove one of those, it'll result in the graph being a function. Alright, number 9 and 10. Use the following table. Okay, so hamburger sales is the title. Number of hamburgers sold is the X, that's the domain. Profit is the Y, that's the range. Okay. 9 says which values represent the domain of the function. So the domain again means X. So we're looking for hamburger sales or 1, 2, 3, and 4. Okay. Or I'm sorry, we're looking for a number of hamburgers sold. Okay. So number of hamburgers sold, that's our X. Hamburger sales is the title. Okay, we're specifically looking for a number of hamburgers sold, or we're looking for these values. That would be the domain. Domain means X. Alright, let's look at number 10, which values represent the range of the function. So we're looking for range, that's Y. So we're either looking for profit or 5, 10, 15, and 20. Alright, so it looks like there is no profit. Profit isn't an option, but 5, 10, 15, and 20. So that is what we want to choose. Okay. Right. Next one. Alright, so for 11 and 12, we're looking at graph for bicycle rider A in the table for bicycle rider B. So first, let's see what 11 is asking for. Which rider has the greater rate of change? Okay, so the rate of change, let's look for A. We're going to look for rise over run. Okay. Alright, so it looks like first the Y is counting by 20. Right, so we got a 20, 40, and then a 60. Right, so the Y's are counting by 20. Okay. Alright, so if I find rise over run here, so there's 2 points it gives me right there. make a triangle. Okay, and it looks like for the rise, it's 3 boxes, and the Y's are counting by 20. Okay, so 20, 40, 60, right? 3 boxes times 20. Okay, so the rise is 60. The X's look like they're just counting by ones. Okay, and there's 2 boxes. Okay, so the run is 2. Alright, so my rise over run for the rate here, it would be 60 over 2, and that's 30, and units are kilometers per hour. Kilometers per hour. So rider A is traveling at a rate of 30 kilometers an hour. Every kilometer they're going 30. Every hour they're going 30 kilometers. Okay. Alright, so let's look at rider B. For rider B, I'm going to go ahead and look right here. Change in Y. Here's our X. Here's our Y. Okay. So it looks like my change in Y is 64. Right. 160 minus 96 is 64. Right. Change in Y. 160 minus 96. That gives me 64. My change in X is 2. Right. 5 minus 3 is 2. Alright, so my rates here for rider B is 64 divided by 2. 64 divided by 2 is 32. Units again, kilometers per hour. Okay, so there are my rates. Okay, which one is the greater value? Obviously, rider B being every hour they're going 32 kilometers. Rider A, every hour they're only going 30. Okay. So rider B has the greater rate of change. Okay. How much greater is the rate of change for the faster rider? Okay, so I guess we'll just how much greater? We're just going to subtract 32 minus 30, and that gives us 2. 2 kilometers more per hour. That's option A. Alright, let's look at 13 through 15 here. Alright, the 2 functions on the graph and table show 2 cars on a 650-mile trip. Use them to answers 13 to 15. Okay, so 13 is just simply asking what is the rate of change for car A. It looks like for car A, it looks like the change in Y is not change in Y, but the increment for Y is 100, 200, 300, 400. Okay, and the increment for the X is just 1. Alright, so if I find 2 points here, I think I see a good point right there and right here. It's kind of small. You see. Alright, so it looks like the change in Y for car A is 100, just 1 box, and the run is 2. Okay, so that's 100 over 2. Okay. Alright, so my rate is 100 divided by 2, which gives me 50. And notice the line is going down. Okay, so it's going to be a negative 50 miles per hour. So they have 50 less miles to go after every hour. Okay, and that's what we're going to choose here for 13. That's option B. Okay. And then for number 14, what's the rate of change for car B? Rate of change. So this is also going to be negative. Look at the Y. The Y is getting smaller. Okay, so it'll be negative, and notice all our options are negative for number 14. Alright, so I'm going to go ahead and deal with these last 2 here. Okay. Looks like the change in y is 260. The change in x is 4. And 10 minus 6 is 4. So I have a 260 divided by 4. 260 divided by 4 is 65. Okay. So, and again, we said it was negative, and y over x, it's miles per hour. Okay, so here's the rate of change, okay, for B. Alright, so it looks like it's option D. Okay, and then the last one, choose the best explanation as to which car gets home first. Alright, let's see which car does actually get home first here. It looks like at 10 hours, car B is already home. At 10 hours, there's 0 miles left to go. Okay, for car B. Just wait for my camera to catch up. And at 10 hours for A, look at A, at 10 hours, they still have about 200 miles left to go. Okay, so B is the one that gets home first. So let's look at our options here. So we know it's not A, right? So let's cross out options A and C. Alright, let's look at the reasoning here. Car B, because it is home at 10 hours, right? 10 hours it's home, while car A isn't home until 13 hours. And we can look at the graph and we see that. And this is what we want to choose. Let's just look at option D real quick. Car B, because it has less distance to travel. Car B actually has, it looks like they have about the same distance to travel, so that's why you would want to choose D. Okay. It looks like car B at the beginning, the initial value for car B was 650, and it looks like for car A, it's also about 650. Okay, so they both had about the same distance to travel. Alright, let's look at the back. Alright, on the back, we got a line graph here. Vincent bikes home along a straight road from his friend's house, a distance of 8 miles. The graph shows his journey. Okay, so let's go ahead and look at what questions they're asking us here for 16. According to the graph, what is Vincent doing from 40 to 60 minutes? So let's look at 40 to 60 minutes. On the graph here, here's 40 and here's 60. It looks like we have a horizontal line between 40 and 60. So his distance from home isn't increasing or decreasing, right? So he must be stopping at rest, okay? So from our options here, it looks like option A, right? Staying in the same place. He's not getting further from home. He's not getting closer to home, right? It's a horizontal line. Alright, let's take a look at 17. During the trip home, at what time frame did Vincent's distance from home increase? So, at what time frame is he getting further away from home? So, we want a line that's going up, right? Because our y is distance from home. So, distance from home goes from 8 to 5, decreased. Goes from 5 to 4 right here. Wait for my camera to catch up. Right there, it goes from 5 to 4. And then at 20 minutes, notice his distance increased from 4 to 6. So it looks like between 20 and 30 minutes, his distance from home increased. Okay, so we're going to look for 20 to 30 minutes. Okay, and then the last one, how much faster is Vincent traveling the first 20 minutes of his journey compared to the last 20 minutes? Okay, so I'm just going to grab a calculator just in case I need it here. Okay, alright, so the first 20 minutes, let's go ahead and get a rise over run for the first 20 minutes. Alright, so the first 20 minutes, it looks like he went 4 miles, right? 4 blocks. And the run, the minutes are counting by 10, so it looks like it's 20. Okay. Alright, so I'm going to put rise over run 4 over 20. Right, 4 over 20. This is his first 20 minutes. Okay, and then 4 divided by 20 gives me 0.2. So for his first 20 minutes, he's going 0.2 miles per minute. Okay, and now let's look at his last 20 minutes. So his last 20 minutes, he got home at 100 minutes. So the last 20 minutes are between 80 and 100. So let's look here. Here's our rise over run. Make a triangle. Alright, so it looks like 2 over 20. Okay, so his rate is 2 over 20. And this is his last. Okay, and 2 divided by 20 is 1/10. Okay, so it's going to be 0.1 miles per minute. Okay, it wants to know how much faster. Okay, so we're going to subtract. Right, we're going to subtract these two. 0.2 minus 0.1. Okay, 0.2 minus 0.1. This is going to give me 0.1. Okay, so paint out just a little bit here. So we're just subtracting what I circled there. Those are his rates. First 20 minutes, the last 20 minutes. Okay, and we're just subtracting. 0.2 minus 0.1 is 0.1. So his last 20 minutes, first 20 minutes, he's going 0.1 miles more per minute. Okay, and these rates should have actually all been negative. Okay, and even if I put it as a negative, the difference between -2 and -1 is just the distance is just going to be 0.1. Okay? I know I can put negative here, okay, if that were the case, but essentially he's going 1/10 mile more every minute. He's getting closer to home. So if I made this a negative, he'd be getting closer to home. Every minute he's going 0.1. He's taking away 0.1 mile for every minute he's going.